CCNA version 7 Enterprise Networking, Security and Automation, ENSA. Addressing table. The names in the addressing table may vary. Also in the topology, the names may vary. But use this topology. And RTR1 is this, RTR2 this, RTR3 this another router, RTRA up here, RTRB this, RTRC this another router. The names may vary, and devices like host A, B, and C, host A, host B, host C, utility server, partner server, utility server, partner server. The names may vary. The names on end devices and servers may vary. Mobile host, this host, and external server, the server connected to the cloud. Okay, obviously cloud simulates internet. You are not required to configure host addressing. Configure OSPF, activate OSPF. Use the process ID 10 for OSPF activation in all routers. Activate OSPF by configuring interfaces of the network devices in the branch 1 network. This is branch 1 network. All this includes these 3 routers. Okay, this router, and this another router included on branch 1. The name of the network may vary, but in my case it's branch 1. And use configuring interfaces. Okay, do not use network statements, use interfaces. Okay, start from RTRT-1 from host A, from any computer, from RS-232 port to console ports. Access host A. Terminal, okay, enter. Enable configure terminal. Okay, first create the process, router OSPF 10. Okay, 10, used for this ID, 10, the process ID. And verify what interfaces will be used on OSPF. Use, for example, gigabit 000. Okay, included on OSPF. Exit from the OSPF process, but now is already created. The interface gigabit 000, IP OSPF 10, and area. The area is 0 when you configure single area OSPF. Area 0. Enter. And also include this serial 010 that connects to HQ network, or that connects this another router. Serial 010. Okay, serial 010. Interface serial 010. And the same command, IPOSPF 10 area 0. And this another interface is serial 011. But this interface is facing Internet Cloud. And to use Internet Cloud, you will use a static default route. And you will configure that later. And serial 011 not included in OSPF process because is the interface connected to internet. Exit. And that is enough. Now from host B, for example, from port RS-232 connect RTR2 console port and host B. Terminal, okay, enter, enable, configure terminal, router OSPF 10, exit, gigabit 000 and gigabit 001. Okay, gigabit 000 and gigabit 001. But another way to verify what interfaces are active, you can do this. Do show IP interface brief. And you will see the active interfaces. The status is up and protocol up. Gigabit 000 and gigabit 001. So configure OSPF on those interfaces. Interface gigabit 000, IP OSPF 10, area 001. The same command, exit. Now configure on RTR3 this router. The name may vary, but connect to that router console host B. Close the terminal and open again. Okay. Okay, enter, enable, configure terminal. And create the process, router OSPF 10, enter, exit, and do show IP interface brief. Okay, gigabit 00, gigabit 001. 00 and 001. Interface gigabit 000. IP OSPF 10, area 0. Gigabit 001. Exit. Very good. Activate OSPF using network statements and inverse mask on the routers in the HQ network. This is HQ network, including these three routers. The name of the routers may vary, but are these three routers. Now, for example, connect from host C to RS-232 on RTRA router console. Desktop terminal, okay. Enter, enable, configure terminal. Router OSPF 10, enter. And here configure the network statements. But show the directly connected networks. In this case are four directly connected networks. 1, 2, 3, 4. And you can list the networks with do show IP routes connected. Advertise these four networks. Okay. Network 10, 10, 0 to 36. 30, the wildcard for 30 is 3, area 0. Okay, now you can see the adjacency with another router. The adjacency between this router and this another router, RTRA router and RTR1 router. Okay, now configure the another networks 4D wildcard 3 area 0 248 wildcard 3 area 0 network 192.168.66.0 wildcard 3 area 0 enter. Very good. Exit. Now connect to RTRB console. Close this, open the terminal again, enter enable configure terminal, router OSPF 10, do show IP route connected. Okay, 3 directly connected networks, configure network 10, 10, 0 to 40, and wildcard 430 is 3 area 0. Enter. Okay, you can see the neighbor adjacency and configure 244, wildcard 3 area 0, and network 192.168.33.0, wildcard for 28 is 15 area 0. Enter. That's it. Now this another router. Change the console. Host C. Close this. Open. Okay. Enter. Enable configure terminal. Router OSPF 10. Do show IP route connected. And advertise these 4 networks. 1, 2, 3, and 4. Network 10, 10, 0 to 44. Area 0. Enter. Very good. 248. Wildcard 3 area 0. Very good. Enter. Network 192.168.44.0. Wildcard for 24 is 255. Area 0. And 55.0. Wildcard 255. Area 0. Exit. Configure router IDs. On the multi-access network routers, these are the routers on the multi-access network. This is multi-access network because these routers are connected to this switch. And this switch creates the multi-access network. So only configure router IDs on these routers. The RTR1 9, RTR2 8, RTR3 7. But the names of the routers may vary. RTR1 host A, enter. Router OSPF 10. Router ID for is 9. Okay, 9. 9. Exit. Okay, RTR2 console. Host B. Close this. Open again. Enter. Okay, enter and router OSPF 10. Router ID 8. Exit. Now this is another router. It should be 7. Close this, open again. Okay, enter. Router OSPF. Okay. Router OSPF 10. router dash ID 7. Okay, for 7. Enter, exit. Customize OSPF operation. Configure RTR1 with the highest OSPF interface priority so that it will always be the designated router of the multi-access network. This is the multi-access network, and this is RTR1 router. The name of the router may vary. We configure the highest OSPF interface priority so that it will always be the designated router. Okay, the interface on the multi-access network is this, gigabit 000, and the highest priority for OSPF in an interface is 255. RTR1 router, host A, enter. Interface gigabit 000. Okay, this interface connected to multi-access network. IP OSPF priority 255, the highest priority. Enter. Exit. On RTR1 router, configure the default route to the ISP cloud using the exit interface command argument. Okay, create a default route to internet, but use the exit interface as the argument, serial 011. Okay, on global configuration mode, IP route the default route and use the exit interface here 11. Okay, sorry, should be this. And don't worry about this message. Serial 11, the exit interface connected to the cloud. Automatically distribute the default route to all routers in the network. Okay, and redistribute this default route to router process. Router OSPF 10 default dash information space originate, enter. Very good, exit. Exit. Configure the hello and dead timer values on the interfaces that connect RTR1 and RTRA to be twice the default values. This is RTR1 router. The name may vary, but is this router, and this is RTRA router. Okay, the interface that connects those routers. In RTR1 router, the interface is gigabit serial 010. And on RTRA router, the interface is serial 020. And configure the hello and dead timer values to be twice the default values. Okay, access RTR1, interface serial 010. Enter. Interface serial 010. IP OSPF hello dash interval. The hello interval is 10 by default, so should be 20. And that interval, the default value is 40, so use 80. Exit. And configure serial 020 on HQ to use the same configuration. Close this, open terminal. Okay. Interface serial 020. IP OSPF hello interval Okay, enter interface serial 020 IP OSPF hello interval. The default value is 10, use 20. OSPF. Okay, OSPF hello interval 20, and that interval, the default value is 40, so use 80. Exit. And you can see the neighbor adjacency re-established. Configure the OSPF routers so that the default cost value for all gigabit interfaces will be 1 and the cost value for fast Ethernet will be 10. By default on OSPF, the auto cost reference bandwidth is 100. This and represents 100 megabits or 100 million. And for gigabit interfaces, 1000 million or 1000 megabits per second, 1 gigabit per second. The cost is rounded to 1. Okay, but this operation is 0.1 and will be rounded to 1. And using this auto cost reference bandwidth of 100 with fast Ethernet interface that uses 100 megabits per second, the cost is only 1. But if you will use an auto cost reference bandwidth of 1000 that represents 1000 megabits per second or 1 gigabit per second, for gigabit interfaces, the cost is 1. And using auto cost reference bandwidth of 1000 for fast Ethernet interfaces, the cost will be 10. And this is the case. Gigabit interfaces will be 1 and cost value for fast Ethernet will be 10. For gigabit interfaces, the cost 1, and for fast Ethernet, the cost will be 10. Okay, this is the case. So I need to configure the auto cost reference bandwidth to 1000. That represents 1000 million or 1000 megabits per second. Okay, but maybe this value may vary. Maybe we'll say cost value for all gigabit interfaces will be 10, and the cost value for fast Ethernet will be 100. Is this another case for gigabit 10 and for fast Ethernet 100? For this, the auto cost reference bandwidth should be 10,000. That represents 10,000 megabits per second or 10,000 million. Okay, but this is my case. Configure auto cost reference bandwidth to 1000. And do this on all routers. RTR1, enter, access the router process, router OSPF10, auto-cost reference bandwidth 1000. Okay, don't worry about this message. Okay, configure on all routers. Exit. RTR2, console, host B, close this, open again. Okay, enter, enable, configure terminal, router, OSPF10, auto cost reference bandwidth 1000. Exit. and change this to RTR3 console. Close this, open again, enter enable configure terminal, router OSPF 10, auto cost reference bandwidth 1000. Okay, very good. Exit. Now host C to configure RTRA. Enter router or SPF 10 auto cost reference bandwidth 1000. Exit. RTRB. Host C, close this, open again. Okay, enter. Enable configure terminal, router OSPF 10 auto cost reference bandwidth 1000. Exit. This is another router terminal. Okay, enter enable configure terminal, router OSPF 10 auto cost reference bandwidth 1000. Exit. Very good. Configure the OSPF cost value of RTRA interface serial 011 to 50. And this interface, this interface serial 011 on this side, the cost 250. Okay, so configure RTRA router on console, host C, enter. Close this, open again. Okay, enter. On global configuration mode, interface serial 011. Okay, serial 011 to 50. Enter IP OSPF cost 50. Exit. Configure OSPF so that routing updates are not sent into networks where OSPF updates are not required. That means configure passive interfaces. And do this in all routers. RTR1 from host A, enter, access router OSPF 10. And for this router, the passive interface is serial 011. Remember that this interface is not included on OSPF process. Serial 011. Passive interface serial 011. Exit. That is enough. For this another router, RTR2. Okay, access the process router OSPF 10 passive interface gigabit 000. Okay. I just configured gigabit 000 because on this side there is now a router snakeboard. Okay. RTR3. Close this, open terminal, enter, enable configure terminal, router OSPF 10, passive interface. This interface, LAN interface gigabit 000. exit RTRA router. This interface gigabit 000. Interface gigabit 000. Oh, sorry, exit access router OSPF 10 passive interface gigabit 000. Exit. All serial interfaces included on OSPF process, RTRB router, change the console to RTRB, console, host C, close this, open terminal again, enter router, OSPF 10, passive interface, gigabit 000, exit, and change this to RTRC router on console. Hold C, close this, open again. Okay, enter router OSPF 10, passive interface, gigabit 000 and gigabit 001. Two interfaces, two passive interfaces, exit. Okay, and now verify OSPF configuration from host A, for example. Close the terminal, open command prompt, and ping host B. The IP address of host B, the name may vary, but is this host 2222? 192.168.22.22. Okay, ping fails, destination host unreachable. Okay. If this ping fails, do the following. Save configurations on these three routers in the multi-access network and then reload them. Okay. RTR1 router, terminal, enter enable, copy running config to startup config, enter reload. This another router, RTR2, host B, enter. Okay, close this, open again terminal, enter enable, copy running config to startup config, enter reload. And finally RTR3, console, host B, close this, open terminal, okay, enter enable configure, copy running config to startup config, enter reload. Okay, reload, and wait for the network convergence for green indicators, green triangles. Okay, test again from host A, command prompt, ping to host B here, this PC on 8168.22.22. Success, repeat, success. Now ping host C. Host C IP address. The name of the host may vary, but is 4444. 4444. Success. Mobile host 5555. Very good. Utility server, the name of the server may vary, but is this 3314. 3314. Success. And finally, the external server. Okay, ping 203.0.113.100. Okay, ping will fail because you need to configure NAT. Once NAT is configured, the ping will be successful. Very good. Now configure NAT. You will configure a static and dynamic NAT at the network edge. What is network edge? This is network edge, the border router to internet, RTR1. So NAT should be configured here on this router. Okay. The name of the router may vary, but is this router. Configure static NAT to translate the address of partner server on LAN A. This is the partner server on LAN A. The name of the server may vary, but is this? And the name of the LAN may vary, but is this? Okay. Configure static NAT to translate the address of the partner server on LAN A to the public address 192.168.115. Verify that the translation are occurring. Okay, on RTR1, host date enter IP NAT inside source static. Now configure the IP address of partner server, the private IP of partner server. Okay, the name of the server may vary, but this is 11.100. 192.168.11.100. Space. And use this public address 192.0.2.115. Okay, so the private IP address of the server will be translated to this public IP address. Enter. And don't forget to configure the interfaces. CL011, the exit interface to internet, is the outside interface for NAT. And this interface gigabit 00 inside for NAT. Interface serial 011. This interface connected to internet, IP NAT outside, and interface gigabit 000, IP NAT inside. Enter, exit. Okay, outside and inside interfaces. Okay, from external server, Okay, to verify this, go to desktop, command prompt, and ping the public IP address, this public IP address 192.168.2.115, ping 192.168.2.115. Is the public IP address of this server, and success. It's working very well, but access RTR1 router from host 8. Close this terminal. Enter enable privilege exit mode. Show IP NAT translation. And you can see the inside local is the private IP address of the server 192.168.11.100. The inside global, the public IP address of the server 192.0.2.115, and outside local and outside global, the IP address of the external server 203.0.1.13.100. So it's working very, very good. Configure dynamic path, port address translation. Create an access list 1 to allow all addresses in the 192.168.0.0.16 network to be translated. Okay, also configure on this router. Enter configure terminal. Access list number 1 permit 192.168.0.0. The wildcard for 16 is 0.0.255. Enter. Create a NAT pool, name it pool-1 case sensitive. IP NAT pool-1. Okay, this name case sensitive. Use the address range 192.0.2.116, 192.0.2.116 to 118, 192.0.2.118. Okay, and net mask, the mask is not specified. And where is the net mask? On serial 011 interface. On this router serial 011. This, and the subnet mask is 29. 29. Okay, 29 is 255, 255, 255, 248. This is 29. Enter. Configure NAT to dynamically use the addresses in the pool for all traffic entering and exiting the company network. Okay, NAT dynamic. And use the pool. Okay. IP NAT inside source list. The access list is number 1. And the pool is this pool-1, case sensitive, pool-1. And when you will configure path, use overload, and that's it. Enter. Don't forget to configure the interfaces for NAT. Serial 011 already configured as outside interface. Gigabit 000 inside already configured, but now configure serial 010. Interface serial 010. IP NAT inside. Exit. and from host A ping external server to verify. Close terminal, open command prompt. Repeat the ping to the server. Success. Configure access list. Configure access control list to meet the following requirements. Use host and any keywords whenever possible. Always explicitly configure the default deny condition when it's to be used as part of the access list functionality, so that it can be logged when the condition is met. You do not need to specify the default deny condition if it is counteracted with permit IP any for this assessment. All access lists should be placed in the most efficient location possible according to the guidelines specified in the curriculum. Create a named standard access list to explicitly prevent all external traffic accessing the telnet lines on RTR1 router. Okay, is this router? The name may vary, but is this router? And configure here on terminal. Enter enable configure terminal. Name it standard access list. IP access list standard. The name BTY block case sensitive. BTY block. Enter. Prevent all external traffic. All addresses on the 192.168.0.0.16 prefix network only should be allowed to access the BTY lines. Okay, permit this network. Permit 192.168.0.0 and use the wildcard for 16.0.0 to 55 to 55. Enter. Configure the default deny condition when it's to be used as part of the access list functionality. Okay, deny any. Okay, standard access list. Enter. Exit. And obviously apply on BTY lines. Okay, line BTY 024, 024, access class, and the name of the access list BTY block. BTY block. Okay, sensitive. Incoming traffic, in, exit, that's it. And verify. Okay, this network includes all the LAN on the 192.168 network, but any other IP on internet or any other external IP address is not permitted. Okay, for example, from host A, from command prompt telnet to gigabit 000 on this router, RTR1 router. Okay, is 10.10.1.17. Okay, and try to access this interface IP address, gigabit 000 IP address on this router, 10.10.1.17. Telnet 10.10.1.17. Okay, is permitting telnet connection. But try to access from the external server. Okay, telnet, and the IP address of the serial interface, serial 001. Serial 001 192.0.2.113. 192.0.2.113. Enter. Close it. Okay, refuse it. So the access list is working very well. Create a numbered standard access list to prevent all hosts on LAN A from accessing LAN B. Okay, this is LAN A. The name of the LAN may vary, but this is LAN A. This is the source. And the destination is LAN B. LAN B, the destination. The name of the network may vary, but is this network. LAN A is 192.168.11.0.24 and LAN B 192.168.22.0.24. Okay, prevent all hosts on LAN A from accessing LAN B. Okay, this is a numbered standard access list. The standard access list should be configured close to the destination. So configure here on RTR3, close to the destination. Okay, and configure this router. Okay, enter, enable configure terminal. Use 10 as the number of the list. Access list 10. And prevent all hosts on LAN A from accessing LAN B. Okay, it's a standard access list. Deny the source 192.168.11.0. Deny 192.168.11.0. The wildcard for 24 is 255. Okay, but you need to permit any other traffic because the implicit deny at the end will deny any other traffic. So you need to permit all traffic. So access list 10 permit any to permit any other traffic. And place this access list on an interface of this router. If this is the source and this is the destination, the direction is from RTR2 to RTR3, and you can configure gigabit 001 incoming traffic or in gigabit 000 outgoing traffic. Okay, I recommend to configure gigabit 001 incoming traffic. Interface gigabit 001 IP access group 10, the number of the access list, incoming traffic. Okay, and verify this. Exit. For example, from host A, try to ping host B. Should be denied. Host A. Close this command prompt. Ping host B. Remember, host B is 122.22. Okay, the name of the host may vary, but is 192.168.22.22. Try to ping that destination host unreachable. But try to ping from another network, for example, from host C, ping 192.168.22.22. Success. Very good. The access list is working very well. Create an extended numbered access list that will prevent traffic from LAN D network from accessing the HTTP service that is running on utility server. This is LAN D, the source, and this is utility server, the destination. Only this host, not the network. The destination is the host utility server. Okay, an extended access list should be configured close to the source, so configure on RTRC router. Go to terminal, okay, enter, enable configure terminal. Number of the list 1 of 1. Extended numbered access list. Access list 1 of 1. Okay, prevent traffic from LAN D. Okay, deny, and LAN D is 192.168.44.0. This is the source. Deny, you need the protocol. The protocol is TCP. The protocol is TCP, and deny TCP from any source. Okay, use host and any keywords whenever possible. So that's why I'm using any instead of using 192.168.40.40. And the destination is the host utility server. Okay, use host keyword and utility server IP address. Utility server IP address 3314. One eighty two 168.33.14 equal to HTTP service www or port 80. Enter. All other traffic from landing hosts should be able to access the network. Okay, if you will deny something, you need to permit any other traffic because the implicit deny at the end will deny all traffic. Okay, and permit IP from any to any. Okay, this is an extended access list. And configure this close to the source gigabit 000 incoming traffic. Interface gigabit 000 IP access group 1 of 1 incoming traffic. 1 of 1 the number of the access list. Exit. And now verify from host C. Try to access the web service on utility server. Close terminal, open web browser 192.168.33.14. Request timeout. The access list is blocking the traffic, very good. But try to access, for example, from host A, web browser 192.168.33.14. Very good. The access list is working very well. Manage network devices. Configure NTP. Configure router RTRB to use utility server as its time source. Okay, configure this router RTRB. Change the console here. Host C. Terminal. Okay. Enter. Enable configure terminal NTP server and the IP address of utility server. Utility server 3314. 192.168.33.14. Enter. Backup iOS to the server. Backup the iOS image file on router RTRB to utility server. Okay, from this router, transfer the image to utility server. Obviously use TFTP server. Okay, on host C, exit to go to privileged exit mode. But first, before to do that, verify the name of your iOS image file, show flash column. Enter. This is the name of the image, iOS image, ISR4330, and this name. Okay, and now copy from flash to TFTP. and the source, the name of the file is this, ISR4330, and all this name, okay, enter, and the address of the remote host, the utility server TFTP server, 192.168.33.14, enter. Destination file name, use this by default, enter. Okay, it may take a while. Okay, success. Okay, this server services TFTP. This is the image. Thank you very much.